Welcome back, everybody. Today I'm going to be talking about the use of tangent plane in orientation control and then highlight a bit of a deficiency in the standard. The reason this is coming up is because I bought a 3-jaw faceplate for my watchmaking lathe and it needed quite a bit of work. So the way that these things work is that the workpiece is held in these jaws and you want the top face of this workpiece to be very perpendicular to the axis of rotation of the lathe. So for that to happen, the workpiece, this top face, has to be parallel to the back face of it. The back face interfaces with this top face of the jaw. This top face of the jaw needs to be really parallel to the back face of the jaw, which is the datum of the jaw. And then this face on the faceplate needs to be perpendicular to the axis of rotation. So looking at the assembly, we've got our faceplate and then our jaws. The datum for the faceplate is this cone, and we want this face to be perpendicular to the axis of rotation. And then the jaws, the back face is the datum, and then we have a parallelism on the front face of the jaw. And sort of a tangent, but if you don't remember what the datum for a cone looks like, it is an axis and a point. The axis extends the length of the cone, and then the point is located where the cone intersects with the axis. And this is a good point for me to show you how this thing actually works. So yeah, it's rotating about the axis, and these jaws move up and down across the surface so that you can hold onto workpieces that are different sizes. So when I first machined it, I got chatter, or waviness on the surface, which is a periodic form error, but it's sort of on a smaller scale, but it's not quite roughness. So it's larger than roughness and then smaller than what one would consider like a flatness issue per se. Although it does fall into, it would be captured in flatness or parallelism, but I got chatter or waviness in the surface. And it kind of looks like this. It actually looks quite nice, but it's not desirable if you're going to be using it as a workpiece. Another side note, waviness. So this is sort of like how you would split it up. So if you had a surface that came out looking like this, you've got this periodic motion or this periodic issue and then some overarching trend. So typically you would consider this to be like the form error and then this to be the waviness error. Waviness and chatter typically come from some sort of harmonics in the machining process. So if you've got a unstable workpiece or it's poorly chucked up, you'll get a lot of waviness and chatter. So I'm going to be looking at this in terms of parallelism because it's a bit easier to draw. But let's say you had a waviness issue or even some sort of like periodic form issue like I did. You could have it where it ends up not meeting your parallelism requirements because of the dips in the surface. But if you remember, in this case, we have a piece that sits on top of it, and waviness is usually quite small. So it's possible that you might have a piece that sits on the surface and actually bridges this waviness. So although the actual surface measures, 0.1 millimeters of parallelism to the datum, if you measured the parallelism of this top face of this piece relative to the datum, you might end up with it being perfectly parallel. And this is where you can use something like tangent plane parallelism. And the idea is that you measure from the high points of the workpiece and measure the parallelism just across the high points. So if I was to measure the surface in terms of parallelism of the faceplate, it would have looked something like this, where there was this waviness, but then there was also a little bit of form error with a dip in the middle, and then the extremities were actually, just about at the right or at the same height. So if we had measured it as a tangent plane parallelism, it actually would have measured, reasonably good, but that is not how this works, right? This is not what the assembly is doing. The assembly is doing something a little bit more like this, where the workpiece is sitting on a portion of the surface. And that, if you measured the tangent plane parallelism in this area, is actually much larger than the tangent plane parallelism across the entire surface. And that's kind of what I did as a check, is I just sort of moved those jaws along and measured, how good is the orientation relative to the axis of rotation, and it changed depending on where it was on the surface. So this kind of highlights a couple of the issues with using tangent plane when you're controlling a form, is that it's only really useful in specific circumstances, and those circumstances are, like we discussed, when the mating part covers the entire surface. If you were to measure, again, the tangent plane parallelism of this, you would expect something quite good, but then if the part only covers a portion of the surface, you might get a totally unexpected result during the actual assembly. So that's number one. Number two, you need those parts to either be very high hardness and resistant to surface deformation, or have a very low contact force. Because you can imagine, if you inspected this surface in the quality lab, you would expect the assembly to look something like this. But then if the surface is low hardness, or there's a really high contact force or clamping force between the two parts, you might just collapse a high spot and end up with a much different parallelism in the assembly than you were expecting. So something that might be interesting to see in the future standards that would help with this first point would be something like a per unit base orientation inspection. And I don't think I've seen anything like this ever talked about, and I did look through the standards, both the 2009 and 2018, and I don't see any mention of anything like this. And I might be having a huge brain fart. But I just don't know how you would suggest this type of inspection or talk about this type of functionality in an assembly. So if anyone knows of a way that you could suggest this type of inspection with the current standards, let me know. But other than that, hopefully you found this interesting and useful. And till the next one.